Our lives are just surrounded by chaos, a constant flood of information. But deep down, we're all driven by this really powerful, almost primal urge to find some kind of meaningful pattern, a clear signal in all that noise.
I bet this has happened to you. You're in a quiet room, maybe an old fan is whirring, and then you hear it. A faint whisper, almost like a distant radio. Maybe you even think you hear your name. It's this weirdly common experience, but what is actually going on there? Well, there's a name for this ghost in the machine. It's called auditory pareidolia. Now, this isn't a hallucination. That's when you hear something in total silence. This is different. This is more of a sensory illusion, where your brain takes real but totally random noise, like that fan hum, and actively shapes it into something it thinks it recognizes.
But this little mental quirk, it's way more than just a party trick. It's actually a window into how our minds are built, why our ancient ancestors survived, and, believe it or not, how we're now teaching our most advanced artificial intelligence to think.
So let's start right here with our own brains. This tendency to find patterns isn't a flaw. It's not a mistake. It's an evolutionary feature, a survival glitch, if you will, that's been fine-tuned over millions of years for one single purpose: keeping us alive. Neuroscientists have a great name for this: the Hyperactive Agency Detection Device, or HAD. Basically, it's our brain's default setting. When it gets fuzzy data, a rustle in the grass, a creak in the floor, that hum in the air, it jumps to a conclusion. It assumes an agent, a thinking thing, caused it. Why? Well, because it's just safer that way. And this chart here just perfectly illustrates the brutal logic of evolution. Okay, so if there really is a tiger in the grass and you hear it, that's a hit. You get to live. If you brush it off as just the wind, that's a miss and you become lunch. The cost of a miss is, death. It's infinitely higher than the cost of a false alarm, which is just you getting spooked by the wind. That false alarm, that's pareidoia. So the bottom line is this: we are literally the descendants of the paranoid ones who ran from the wind. Natural selection favored the brains that were jumpy. Being wrong 1,000 times was a much, much better survival strategy than being calm and being wrong just once. Now here is where things get really wild. We are taking this evolutionary glitch, this exact same drive to find a signal in the noise, and we are intentionally building it into our artificial intelligence. So take a project called Aural State. Our brain takes the raw data from a fan and spits out the signal of a voice. Aural State does the same thing. It takes raw, noisy server data, like CPU stress or memory usage, and it turns that into a meaningful signal, a sound that changes, letting an engineer literally hear if their system is healthy or not. Okay, so that's a pretty elegant way to turn data noise into a useful signal. But things get truly fascinating when we give the machine more senses. What happens when an AI can see a screen, remember what it just did, and then decide what to do next? Well, that's where we get something like the LLM vehicle. This AI works on what's called a recursive feedback loop. It sounds complicated, but just think of it as a cycle. First, it sees the noise, a screenshot of your phone, for instance, and it remembers what it just did. Then it processes all of that to find the signal. What is the most logical next step here? It outputs an action, like a click, and then it stores that click and the new screen in its memory. And then the whole loop starts all over again. And that loop is what makes all the difference. It's what separates a simple tool from a cognitive agent. By giving the AI this kind of short-term memory, we give it temporal awareness. It's not just reacting to one thing at a time anymore. It's starting to understand the flow of a task. It gets cause and effect. But this is also where a new kind of risk pops up. I mean, if our own brains can make us jump at the wind, what happens when an AI starts seeing causes that aren't really there? This drive to find meaning and figure out cause and effects isn't just something we're building into machines. It's the same impulse that is deeply, deeply embedded in our culture, shaping the very way we tell stories. So take the character of Lanny from Max Porter's novel. Lanny is, well, he's not just a boy. He's like a psychic sponge for his entire village, absorbing everything around him. He describes this experience with one really powerful line. The entire character is really just an artistic exploration of our theme. The book calls him a cohesion of all the voices and habits in his village. He takes in all the social noise of his environment, and from it, he creates his own unique identity, his own signal. He's a walking, talking example of pareidolia. We also see this idea built into the very structure of our stories. The whole story within a story thing is a classic device that puts us, the audience, in the position of a signal finder. We have to sift through all these layers of narrative noise to find the central theme, the true meaning. And you see this technique everywhere, in some of our most beloved films. In The Princess Bride, we're listening through the filter of a grandfather reading to his grandson, interruptions and all. In Inception, we have to go down through layers of dreams to find the core idea. And in the Grand Budapest Hotel, we get a story told by a man who heard it from another man years ago. Each layer just adds more noise, forcing us to actively hunt for the truth at the center. So let's bring this all home. This one fundamental drive, this constant search for a clear signal, it's not isolated to just one part of our lives. We've seen this same pattern in our evolutionary wiring, in the architecture of our AI, and in the very structure of our art. It's a universal constant, the drive to find order in chaos, to pull a clear signal from an overwhelming amount of noise, is one of the most fundamental things about being human. It's how we survive, it's how we build, and it's how we create meaning. And this whole process of creating meaning happens on a massive cultural scale. Take this data, for example. It's from the Best American Poetry Anthology over the last 5 years. It tracks which literary journals most often have their poems selected as the best. Think about it. There are thousands of poetry journals in America, a massive sea of noise. But our cultural institutions, they act like a giant filter. They select, they anthologize, and they elevate a tiny fraction of them, basically anointing them as the top tier. They create a clear cultural signal for what great poetry is supposed to be. And this leads us to one final, fascinating question. We started with the very human tendency to hear ghosts in the noise of a fan. But now we're building machines with that same core function. So as these AIs get more and more sophisticated in their search for signals, what phantom voices, what strange patterns, what ghosts will they begin to find in the noise we feed them?